The standard error of the estimate is 20.2853, as it is shown here in the linear regression analysis results. Now, how are we going to test the new hypothesis? We're going to take the hypothetical value of the estimates and subtract it from the initial value of the estimates from our results. Then we divide that by the standard error of beta 2, which was taken from our results. If you carry out the calculation, you will get a value of minus 0.015. The next thing to do is to draw the normal distribution curve, which is also a bell-shaped curve. Now, we need to find where the t critical value, which we got from the t table here previously, by crossing the degree of freedom from our results with the alpha value on the t table, which is 0.05, to get 2.145. Now, the region in between that value, the negative value, that is 2.145 on the negative side and 2.145 on the positive side. The region in between these two values is the acceptance region. If the t-test value falls within the acceptance region, we're going to accept the null hypothesis. But if it falls outside the region, the part that is shaded red on both sides, we're going to reject the null hypothesis. Now, our null hypothesis says that an increase in $1 in income will not cause consumption expenditure to increase by 1. Now, because our t-test value falls within the acceptance region, we're going to conclude that $1 increase, like an increase of $1 in income, will not cause consumption expenditure to increase by 1. Now, let us use our model for forecasting or prediction. Suppose we want to predict the consumption expenditure for 1997, and we know from record that the GDP for USA in 1997 was $7,269.8 billion. Remember that our estimation is this. Now we're going to substitute X with $7,269.8 billion for 1997 model. Now, when you do this calculation, you will see that consumption expenditure in 1997 by using our model is $4,951.3167, which is approximately $4,951.32 billion. But in reality, the consumption expenditure of USA in 1997 was $4,913.5 billion and not $4,951.32 billion. Therefore, the model overpredicted the amount of consumption expenditure by 37.82. There is a difference between the forecasts that was made by using the model, by using our estimates, and the reality, that is the real value of consumption expenditure in USA in the year 1997. Therefore, the error term that I have mentioned when we specify the model, that is the Greek symbol that is shown in the model right here. That error term for the year 1997 is the difference between the forecast and the real value of consumption expenditure. The error term is $32.82 billion. It is also referred to as the residual. Suppose the government decides to reduce income tax. What will be the effect of such policy on income and eventually on consumption and employment? Let us assume that the policy caused investment expenditure to increase. Please note that Keynes' general theory says that a change in income as a result of change in investment expenditure is given by the income multiplier, which is represented by M, and it is defined as 1 divided by 1 minus MPC. MPC is the marginal propensity to consume. It is defined as the proportion of an additional income that a consumer spends on the consumption of goods and services instead of saving it. Remember that the initial theory that we've been talking about in this video is Keynes' theory that says that the rate of change of consumption as a result of a unit change in income is greater than 0 but less than 1. The rate of change of consumption that we've been talking about, that Keynes was referring to, is also MPC, that is marginal propensity to consume. It's also the rate of change of consumption. Now, from our estimation, the rate of change of consumption is the coefficient of the independent variable, that is income. Remember that I told you that when there is 1 unit increase in income, the rate of change of consumption expenditure, which is Y, will be 0.706. Therefore, MPC, which is also the rate of change in consumption, is 0.706, as it has always been in the estimation results. Now, the multiplier that we mentioned here, the income multiplier, is now 3.33 when you insert the value of MPC in the formula. This means that $1 increase in investment expenditure will cause a triple increase in income. That is, when income multiplier is 3.33, there will be a triple increase in income with $1 increase in investment expenditure. Note that this effect does not take place immediately. It takes a little while for these effects to kick in. Do you realize that we couldn't have obtained the estimate of MPC without the regression model? Now, let us use our model for control and policy purpose. Suppose the government believes that the consumption expenditure of $4,900 billion will keep on unemployment rate at its current level of 4.2%. What level of income will guarantee the target amount of consumption expenditure? Now, we're going to use our model, our estimates again. This time, we're going to substitute Y by inserting $4,900 billion here in place of Y, so that we can obtain the value of X, income. When you solve this equation, X will be $7,197.17 billion. This means that an income level of approximately $7,197 billion, given an MPC, that is rate of change in consumption of 0.70, will produce an expenditure of about $4,900 billion. Now, I've come to the end of this video presentation. There's going to be another video on assumption of OLS. The books that you can study to understand further the idea of linear regression analysis is Basic Econometrics by Gujarati. For correlation, you can study a book written by Daniel Stockinger titled Quantitative Methods for the Social Sciences. I want you to know that statistics and econometrics can be a lot of fun if you pay enough attention and you try to develop interest in it. Thank you so much for watching this video. I really hope that you enjoyed it. If you have any question, you can put it in the comments section. Have a great day.